We're here in the lab this morning at Diverse Dimensions, and we've got a reverse engineering project that we're going to be working on today. We've got to track all the geometry on this die block here, but my client has specifically asked for an alignment that's based on the corner of this block. The corner that would be made up of this plane here, this side plane here, and then its bottom face, which is actually on the table right now. So what I'd like to do is show you guys how we're going to do a three-plane coordinate system and then turn that into the CAD equals part alignment. So I've got X up today, so why don't you zoom on in here a second and we'll take a look at how we'll do this in the software and right here on the table. Now I've got my block positioned on the table here, so I've got this side exposed as well as this side here, and then the bottom face is right up against the table here. So what I'd like to do is construct the coordinate system that's going to be between this plane here, and then this side here. And I've got my quantum today. I've got my 1 millimeter probe on here because some of the detail that's on the back side of this needs to be tracked with a 1 mil probe. So the way I'm going to do this, though, with my constructed coordinate system, this three-plane coordinate system, is I'm going to first measure my planes. So I'm going to do this. I'm going to go to the Measure pull-down menu and go Plane. Now it's asking for a single point, or it's asking for point 1 in a plane. Single point mode is selected. So I will start by just tracking around on this table. Ever so gently with this 1 millimeter probe. It's a little bit more fragile. Then I'll compensate away. And then, of course, I always name these planes. So I'm going to say that this right here is my tabletop. And then it's expecting me to keep measuring planes here, so I will do that. I'm going to hit this back face right here. And this is all one face by design, so I'm going to continue this plane all the way across here with 4 points. Compensate away. Never cross my geometry. I'm going to call this plane the front face. And I look at my form. I've got a form of 4/10, which I'd expect. It's a die block that's very well machined here. So I will say OK to that. And then what I'll do is this face right here. And I'll do that with 4 points as well. And compensate away. And then this one I'll call the side face. And enter that. Now I'll hit escape just to get out of the measurement here and hit E for everything. Now notice what I've got on my screen. It looks like I've got a couple planes on there and I've got some labels on there, so let me just move those out of the way for you a little bit. But now my client specifically asked that this corner be set up as my constructed coordinate system origin. So pretty easy to do with our construct a coordinate system, and then with that down arrow there, it is known as the three-plane coordinate system. And as I was measuring these planes, I just made sure that my sequence was in the order that I'm going to pick these planes. I wanted to pick the tabletop first as my primary. And again, I named them so I know exactly what those planes are. So tabletop there. And then I'm going to go with the front face and then the side face. So I'm going primary, secondary, and then this will be my tertiary plane. So I'm going to say OK to that. If I wasn't sure which planes I was picking, if I had a lot of geometry all over this, what I could do is hit the view just to make sure that I'm picking up appropriately on the right planes. But I'm going to say OK here because I think I'm doing pretty good. And then there's my constructed coordinate system that comes out. And I will say OK to that. And notice what happens is I will zoom out and then in just a little bit. You'll see my plane labels are still on here, but now my coordinate system is right at the intersection of this table plane, this front face plane, and this side plane right here, this side face. So right on the corner of where all three of those planes intersect is where that origin is. And then the very next thing I do is go to the alignment and CAD equals part. I want to tell the arm that its coordinate system is actually right here. So I'll say OK to that. There's the alignment, and I'll say OK. So there you have it. I've got a pretty fast way of grabbing all this geometry here and putting them into this constructed coordinate system. And here's a little trick. If you want to hit the L key, L for label, moves the labels to the outside of this view, so I can just make sure that I'm actually right there. One way I would check this too, let me zoom out just a little bit more. I would go to this measure, and then with the down arrow, I'm going to go to this inspect XYZ. What that's going to do is show me right where the probe is. And if I bring the probe in, I should be pretty close to my origin. And it is. You can see that right there. Well, okay, I like that. And also notice my DRO. In fact, I'm going to bring that in just a little bit closer here. I'm going to pull it right down here. And then I'll go back to the measure, inspect XYZ. And now notice if I'm right into that origin, right into that location where my origin is, my XYZ is pretty close to being where 0 is. So that's what I like to see. That's a good way to double check to make sure that my coordinate system truly is my origin, and that's truly in this corner. And that's set up off that 3-plane constructed coordinate system.